Welcome back to my YouTube channel. We've given the question 1, which is partial derivative, which is N6 mathematics. Question 1, we have given 1.1. They said z is equal to sine into x multiplied by 1. That is what we're given. Our argument there is that x multiplied by 1. Then they say we should prove that partial derivative x, the derivative of x in respect to y minus derivative of y in respect to x, partial derivative of z respective to y. We've given that we should prove these 3 marks then. So which is 1.1. Given 1.1, we have to prove we'll subtract this. That is what we want to prove there. The aim is to prove that, as we've given that y is equals z, so about that z is equal to sine into x multiplied by y. So we should prove this here, right? So first one, we can use the first one here. Let's check. Let's do what is partial derivative z in respective to what, to y, as you can see. Then in respective to y, this will simply equals to x. Remember here, in respective to y, x will be like a constant. We'll treat x as a constant. Will be y multiplied by what, the derivative of sine, which is cos, what is inside x multiplied by y. We use the chain rule. Cannot be, so will be x. Remember, x is a constant. You multiply by the constant, multiply by cos x y, right? Apply this. Is a chain rule. X is the same as a constant, right? It's the same as a constant. So this is what we have there. Now let us check. Let us again find the partial derivative of this z in respect to x. Here we have partial derivative of z in respective to x. This will be, we're still obvious, we're still focusing on this. Here it's our main thing there. We're still there. If we now, because respective to what, to x, that means y will be what, a constant. We apply chain rule, will multiply by y. What is the, when you differentiate sine, we know what is sine. Sine is simply cos, then what is inside, like this. We have that. Now let us follow this. Now you will use that. We minus this. Now we'll apply that. Now we can use that because they wanted us to minus this, right? Isn't it? So let us minus this. It will be equals to you take this one, will be x cos x minus x. You saw about this, x multiplied by y minus, yes, we have minus there, y cos x multiplied by y. This is what we have. Let us check, do we have common factor here? Okay, we have things that are common, which is cos and cos, but they said we should prove what here? We should prove this, isn't it? They just factor. You see, let us write it as they have written it there. We know we'll have, if we take out the common factor of that, we'll remain with x minus y. Then we're left with cos x multiplied by y, which is what we have proven. We have proven this, isn't it? So yeah, that is what we have there. It's fine. So we have given now 1.2. We have given these things here. As you can see, we have given y is equal to a sine theta minus a theta cos theta, and x is equal to a cos theta plus a theta sine theta. Determine the derivative in respective to what, to x. As you can see, that is not partial. It simply was that they said we should in respective to x, or fine, still we are we're dealing with partial derivatives, right? No problem. This is still partial derivative. To find this, because you've given two things, we must know, okay, it's fine. 1.2 are given that y is equal to a sine theta minus a theta cos theta, right? And sorry about that. And x is equal to a cos which is theta there, cos theta plus sine theta. So we want that, they said we should find dy over dx, so it's fine. Now we want dy over dx, which is 2.1.1. dy over dx is 1.2.1. we want dy over dx, right? To find this, now we have to do some gymnastics. There. That is what we want, what you've given. Okay, I can start by this. You've given the equation 1, which is y is equal to a sine theta minus a theta cos theta, right? So we'll take the partial derivatives, or you can use, or you can take derivative in respect, or okay, let us take derivatives. Let us not take partial, let us take derivatives, but we'll take this derivative in respect to what? We'll take them in respective to theta. Let me take it in respective to theta. I can say dy over dx, d theta. Here a is the same as constant throughout. So since a is a constant, we know that we'll simply a, then what is the derivative of sine? We simply positive cos theta. Then but now when we come here, okay, we have minus here, no problem. But this one, as you can see, these two will use product. Remember, this is a constant, right? A is a constant, but this we don't take it as a constant. You see, in respective to theta, that there will matter. We will apply product rule. We know a product rule, right? Product rule f prime, because there I will say f prime theta, because you have theta, g theta plus f of theta multiplied by g of prime theta. Apply a product rule. We apply and on only here that is what we want there. This is, remember that it's a constant. A is a constant. So if you apply the product rule, you must be careful there. You want to apply product rule. A, remember this is f prime, right? So it's up to you which one you make it f prime there. It's up to you. You can make we can make theta It's up to you whether you make theta f prime or you make g cos theta g of prime. It's up to you, right? So if you differentiate that, now we apply this. I know that can say if we apply, we use the product rule. A is simply just a constant, isn't it? A is a constant, it's what I know. Then f prime I made to be theta. This will simply equals to what? 1. Right, multiply by 1. This one will remain as it is. G of x is cos theta, will remain as it is, right? Plus g of x will remain as it is. A is a constant. Don't forget that a is just a constant. Will be theta. That is what we have. There will be theta. Theta will remain as it is, but g prime theta cos is cos, right? Cos theta will when we differentiate cos theta is simply what will be when we want to differentiate that, isn't it? If we differentiate that, will be negative sign, isn't it? So this will affect this one, will be minus a theta multiplied by sine of theta. This is what we'll have there, actual. You understand? That is what you'll have there. So without wasting time, guys, as you can see, that is what you'll have there. So dy over d theta simply equals to a cos theta minus a cos theta, right? A cos theta is what we have there, minus a cos theta. Remember, this is plus positive, sorry, there, minus cos theta, as we have there, plus a theta multiplied by sine theta. This is what we have, right? So for the first one, this is what we have, but let's check what is common here. We have a common thing. There's something which is common. There's nothing common, but this and this must cancel. As you can see, it's the same. We'll have dy over d theta, which is simply equals to a theta multiplied by sine theta, right? That is what we have, sine theta. So this is what we have so far, guys. So this is what we have. Sorry about this. Sorry about that. For the screen rotation, there's some noise there. So we have find this. So let's go to equation 2. Remember, we've given 2 equations. We have did this, but we've given also of the x. So the one of the x, we have x is equals to a cos theta plus a theta sine theta. Then will be d, take dy again in respective to d theta. Oh, that cannot be d, is dx, sorry, cannot be dy, is dx. Remember, the here we have x, isn't it? Will be dx over d theta will be simply equals to this. It's a constant. There's nothing will change. But what about this? Will be negative sign, negative a. Right, this is negative sign, so will affect a. So we'll simply write as negative a sine theta. Then here we'll apply your chain rule. We'll apply our product rule. Will be that. Then g of theta would be sine. It's up to you when you apply that. If I apply this, I'll simply have plus a, it's a constant, differentiate theta simply 1, then we'll have sine theta. 1 multiplied by that will be sine theta, then is what we have there. Then I have plus, since it's this thing here, g of theta, now we have that. We have a, okay, a is a constant, it's always there. We have theta, we don't differentiate theta, we differentiate g of x, g of prime, which is sine, which will be what? Cos theta. So this is what we have, simply just like that. So d of x over, this is the same, as you can see, we'll have a theta cos theta, right? Then what was the question saying there? It was saying determine dy over dx, isn't it? Dy over dx, which, what is this? It's 1.2.1, 1.2.1, then that is what we're supposed to have. Dy over dx is fine. Dy over dx will simply equals to, check here, we'll have dy over d theta over dx over d theta. Why? As you can see, because if we multiply, this will cancel mathematical. We'll have, okay, we'll do that, we'll have that, this will form this. So dy over dx will simply equals to this dy over d theta. Dy over d theta, what is dy over d theta? We have calculated dy over d theta, we said is this is what we have there. Simply have to substitute there. It's a theta sine theta all over dy over dx is this one here. So simply what, a, we have a theta, what, a theta multiplied by cos theta. So mathematical, these two cancel, we have dy over dx, simply this is tan, sine over cos is what will be tan theta. So yeah, we have found that. What about question 1.2 or 1.2.2, d2 over case the second derivative? So we know that this is a partial, right? We have that, so we shall find d over dx2. Okay, can use this formula, as you know, will be d over d theta is what we have found firstly, into dy over dx all over dx over d theta. So this is what we have. So we have found this. Remember, you got this, we have this, we also have this. Actually, as you can see, this is tan. Here we will substitute tan theta. So let us substitute. This will be equal to d over d theta into tan theta all over dx over theta, where it's our dx over theta, dx over, here it is, as you can see, dx over theta is that, simply a theta multiplied by cos theta. So here on the top, we differentiate. Remember, this is the differential again. You differentiate again. Remember, d over d This is simply differentiate again. That will simply equals to secant squared, if you know, secant squared theta all over a theta multiplied by cos theta. Then if you know your maths, this is the same as 1 over, like that, it's the same as 1 over cos squared theta. Then let me change this division to be like this, to be like a division straight. This is the same as theta, the same as a theta cos theta over 1, right? Then you know your maths. To change this will be multiplication. You invert that, you take the inverse of that, will be a theta cos theta. So then we multiply 1 multiplied by 1, does not change net. Then we'll have 1 there on the top. This, when you multiply, we have a theta, but cos, and cos will be cos cubed theta. So if you know there your math, if you can check this, is simply what is that? We'll simply have what then, if you can check here, we'll have 1 over a theta, but what is this? And it's, let me write here in a nice a theta, right? But it's over 1, isn't it? Because it's on the numerator. Into what is that? It's a sec. 1 over cos is sec, but now we have raised to the power of 3, will be 3 what theta. So this is what we'll have, the final value, guys. So yeah, these are our necessary steps. So guys, thank you for your time. Please do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Thank you.